The black graph is the graph of y equals e to the power of x. To see what the number e is, you can go to your calculator, of course, and just press this button here, and here it is. There's no pattern to it, and this decimal doesn't terminate. So to one decimal place, e is 2.7. Now here we have the graph of f of x equals b to the power of x that we covered in the previous video, and you can see I can make it coincide with e to the power of x if I make b about 2.7. Of course, all these graphs, as we saw previously, pass through 1 on the y-axis. Now from calculus we know that this function is special. The derivative of this function is itself. The derivative of e to the power of x with respect to x is e to the power of x. Now let's look at a point on the graph of e to the power of x and the tangent through that point. So here we can see that when x is 1.8407, f of x, or y, is 6.301. I'm just going to call this f of x now instead of y. So the derivative of the function at this value of x, 1.8407, should also be 6.301, because the derivative is the same as the value of the function at x. So the slope of this tangent should be 6.301. Remember, to get the slope of a line, we can pick any point on the line and increase x by 1, and then see by how much y changes. So the change in x here, delta x, is plus 1, and you can see that the change in y, or delta y, is 6.301 units. That's the same as the y value of the point. That's only true for this function, of course. So we can write the derivative like this: f prime of x is the slope of a tangent to the graph of e to the power of x at any value x. Now let's see this in action here. I'm indicating f of x here and f prime of x, where we have the x value of this point. Notice that the slope of the tangent is always positive for all points on the curve. The tangent is becoming horizontal as x gets smaller and smaller. Its slope is approaching 0. Now, like the previous video, I will look at a more general case of an exponential function, where we have this parameter b, the coefficient of x in the power, and we have a factor, scale factor, in front of the function, which I'm calling capital A. Now in the previous video I called the parameter in front of x c. I'm calling it b here. The difference here, of course, is that the base number is fixed as the number e. In the previous video, this number was any number. So here's the situation for positive value of b. B equals plus 0.5, and just like in the previous video, we know what happens when b is increased. The function becomes steeper. I've a set at 1 here for the time being. We know that the graph passes through 0, 1. It actually passes through the value a on the y-axis. So a is 1, so it passes through 1 on the y-axis. Now let's vary a, and as we saw in the previous video, well, just like what I just said, you can see what's happening. The graph, the coordinates of this point are 0, a, so a is 3.4 here. Now if I make a negative, well, the graph will be reflected through the x-axis. Well, let's see what happens when a is 0. Well, when a is 0, it's pretty obvious what happens. Our function f of x becomes equal to 0. This is 0, of course, so we just have a horizontal line passing through 0. Now look what happens when a is negative. For example, if the function is minus 0.7 e to the power of 0.8x, this is the image of the graph of plus 0.7 e to the 0.8x reflected through the x-axis. So let's look at the graph of plus 0.7. So here it is. So the graph that you just saw is the image of this graph here under axial symmetry in the x-axis. So I'll go to minus 0.7 again. There's minus 0.7 and there's plus 0.7. Now what's more important for us is to consider the situation when b is negative. So first of all, I'll bring b to 0. So now we have the graph of f of x equals 0.7 times e to the power of 0. Well, that's just 0.7 times 1, or 0.7. So we have the graph of f of x equals 0.7. It's a horizontal line passing through 0.7 on the y-axis. Now, see what happens when b is negative. As I explained in the previous video, the orientation of the graph changes. The graph is a decreasing function of x. So as x gets larger and larger, as x tends towards plus infinity, f of x is approaching 0. So the graph is approaching 0, just like you saw in the previous video.